Okay, notes 3, Introduction to Functions. So we're going to talk about a couple concepts here. The first one is a definition of a function, the vertical line test, function notation, finding function values from a graph, and then the domain of a function. So first, definition of a function. It says, given a relation in x and y, we say y is a function of x if for each element x in the domain, there is exactly one value of y. So for each element x, there is exactly one value y. In other words, what this means is that we should have no two ordered pairs that have the same first coordinate, okay? So this is a no, we don't want that, okay? If they have a same first coordinate, that means we have repeating x's, okay? Which we do not want repeating x's. Repeating x's means not a function, okay? Repeating y's doesn't really matter, just repeating x's. So looking at the first one here, remember in order to read these maps, we are looking at the x and then following the arrow to the y. So if I was to convert this to points, this would be 1, 3 and 1, 4 because the 1 is going to 2 y values and then 2, -1 and 3, -2. So since we have 2 1s in the x values, which means our x's are repeating, we would say that no, this is not a function. Okay. So I would do that for each one. I would follow the arrows and make sure that the x's are only going to one y. Okay, so for these ones, 1 is going to 4, 2 is going to -1, and 3 is going to -2, or +2, sorry. 3 is going to +2, which means there's no repeating x value, so yes, this is a function. Okay. This one, 1 is going to 4, 2 is going to 4, and 3 is going to 4, which means we have repeating y values, but that's okay as long as our x values are not repeating. So we would say, yes, this is a function. Okay, looking at this one, we see 2 is going to 12, 6 is going to 10, and 7 is going to 13, which means they all have unique values. We don't have any repeating x values, so we would say, yes, this is a function. Okay, here they gave it to us in ordered pairs. So here I would just go through every single one and I would highlight all my x's, and then I would think to myself, okay, do any of these repeat? Well, if none of them match and none of them are repeating, then I would say, yes, this is a function. Same thing for this one. I would look at each of the x values, see if I find any of them that are repeating, and I see here that -1 is there twice. So since it's repeating, then I would say, no, this is not a function. The next concept is the vertical line test. It says, consider a relation defined by a set of points x and y. The graph defines y as a function of x if no vertical lines intersect the graph in more than one point. So for example, this one is not a function because if I was to draw a vertical line through all parts of this relation, notice that I have these points right here both going through the same vertical line. That is why it is not a function. Versus this one over here, if I was to draw a bunch of vertical lines, okay, I would notice that each of these vertical lines only have one point going through them. And since there's only 1 point and there's no more than 1 point, we would say yes, this is a function. Okay. So looking here, I can do the vertical line test. So I'm going to draw my vertical lines and I'm going to see how many times it crosses through those vertical lines. Since this crosses through 2 times, I would say no, this is not a function. Okay. Same for this one. I would do a couple vertical lines. I would test to see how many times my vertical lines pass through my equation. And since it only passes through once, I would say yes, this is a function. Same here, I'm going to draw a couple vertical lines. I notice that it only crosses at 1 point, so I would say yes, this is a function. And then the last one here, I would draw a couple vertical lines, and this is where it's important to draw several vertical lines, because look right here, if I was to only draw this one, well, I'd be like, well, it only intersects at that 1 point, so maybe it is a function. But in reality, I would have to check more parts on here to see how many times this vertical line would cross the function. And notice that middle vertical line, it crosses 4 times, so this most definitely is not a function. Okay. Next concept is function notation. So function notation means they give us a function, an equation, and they're going to give us a number to plug in for x. Okay, so all of these inside the parentheses are representing x. So g of 0 means I'm going to do 1/2 times 0 minus 1. So instead of this x, I plugged in a 0. Well, 1/2 times 0 is 0. Bring down the minus 1. 0 minus 1 is -1. So I have g of 0 equals -1, or the point 0, -1. This would be ideal. I would want you to write your answers in points when possible. Okay, next I would plug in 2. So 1/2 times 2 minus 1 is 1 minus 1, which is 0. So g of 2 equals 0, or the point 2, 0. Okay. Then I have g of 4. So I have 1/2 times 4 minus 1, which is 2 minus 1, which is 1. So g of 4 equals 1, or I have the point 4, 1. Okay, next, -2. So I have 1/2 times -2 minus 1. This is -1 minus 1, which is -2. So I have g of -2 is equal to -2, or in other words, the point -2, -2. Okay. Same thing over here, but now I am plugging in these numbers into x for my new equation. So f of 1 is -2 times 1 minus 3, which is -2 minus 3, which is -5. So I have the point 1, -5. F of 0 is -2 times 0 minus 3. So this is 0 minus 3, which is -3. So I have the point 0, -3. Okay, then I have f of -3. So I have -2 times -3 minus 3. This is +6 minus 3, which is 3. So I have the point -3, 3. And then lastly, f of 1/2 is -2 times 1/2 minus 3. -2 and 1/2 is -1. Bring down the -3. So this is -4. So my point is 1/2, -4. Okay. Now those are pretty simple because we were only plugging in one thing, and that was a number every single time. Well, now for these ones, instead of plugging in just a number, we're going to be plugging in sometimes a different variable. So each of these are still going to represent x. Okay, And then notice how they're also mixed. I have some F's and then I have some G's. Just know that F, these ones have to go with the F function, and G has to go with the G function. So F of t means I'm going to do t squared minus 2t. So instead of x, I put in t. And then F of negative t means I'm going to do negative t squared minus 2 times negative t. So this is going to be t squared plus 2t is equal to f of negative t. And then for this one, I'm plugging in w plus 4. So I'm going to do 3 times w plus 4 plus 5. And again, let me move this. Okay, so I can simplify this